kind of what we're going to do today. We're going to continue more substitution, just doing some practice, making sure we really have a good grasp on that. And then get in a little bit to elimination, which is our last method. And then we'll just kind of continue practicing next class as well. So I'll show you the calendar. I changed some stuff around. But I wanted to do this little breakdown sheet, just kind of like reviewing substitution and what that process looks like, and writing some steps. And then we're going to go to those puzzles and do a couple more of those practice problems. Because, again, it's just one of those things that's a lengthy process. And so it's really good to be able to break it down, know the steps, be able to kind of talk about it, and then go from there. So remember, we're still under this big umbrella of solving systems. And regardless of which method we use, we're always doing the same thing. We're finding the point that the lines have in common, that they cross, that they share. So how many, we've kind of talked about this, but what are our possible number of solutions, our possible number of solutions that we can have?
So the first one will be no solution.
Okay, so we can have no solution.
And the second one
Okay.
will be
You want to have that? A solution? How about one solution?
one solution.
Because there could be, if there is one, there could be one. So there could be none at all. There could be one. Was our last case?
And it's all.
All or infinite. And y'all don't have to write both of those. It's just totally up to you for how you write that. So that's the case where every single point is shared. So we've shown graphically, and we're going to draw kind of small because I want to write examples graphically, what that looks like, and then also algebraically. So graphically, a no solution graph, what would that look like? Parallel. Two lines that never cross. I'm going to do parallel lines this way. Parallel lines have the same slope. You are correct. Thank you. So we have reviewed this every single day, and y'all, I'm telling you, you're going to need to know this. I'm going to ask you on a test, give you some pictures or give you some equations and expect you to be able to tell me how many solutions there are from that. So that's kind of graphically, and that's what we did the first day. But then we learned one algebraic method, substitution, and then the method that we're going to kind of start talking about today also is algebraic. And you can still have these cases, but with these algebraic methods, we don't look at the graph at all. Even though we're finding a point of intersection, we don't look at the graph at all. So if you have a one solution problem using substitution, you're actually going to get a number for x and a number for y. That means that there is one. And then you would write it as an ordered pair, x comma y. So you'll be able to actually solve. Every example you did last class had one, well, actually that's a lie. All but one example had one solution. That's your most common case because we're not going to give you like 20 problems that have no solution because that's just kind of silly. So most of the time you're going to have one, and again, you are able to solve for it. But then I believe you guys, did y'all do the all solutions example?
Yeah,
Okay, so that problem, when you were working with your algebra substitution, you got left with something like this. 4y equals 4y. Did y'all talk about whether that was true or false? Mm-hmm. Is that true or false?
True.
It's true, the exact same thing. So that meant, because we were left with a true statement, infinite solutions. What about something like this? Look at what I wrote.
False.
5 equals 5. You didn't even look at what I wrote. 5 equals 5. True or false? True. So even if it's not variables that are left, it's just numbers that are left. If it is a true statement, two numbers equal to each other exactly, that would imply it's infinite or all solutions. What about this one? 0 equals 0. True or false? True. So anything that is a true statement, that's going to be all solutions, true statements. Whether it's variable equal variable, exactly number equal number. I think most of the time it's numbers. But again, we did see that one example in class. It was 4y equals 4y. So if true statements mean that it's all solutions, what kind of statement you think is going to mean no solution? False statement. So what about this? 0 equals negative 10. Wrong. That would tell me that's no solution. What about 4 y equals 4y plus 1. That will be false again. So anything that is false would give me a no solution. Okay, so it's good to be able to kind of know the idea. This is just giving you the number. It's not actually giving you the actual solution if it's a 1, but that's just kind of our possible cases that can happen. Okay, so when should we use substitution? So we're going to get to, after we've learned all the methods, I'm just going to give you problems. And then you're going to have to be able to say, okay, I think I need to use this method because blah, blah, blah. I think I need to use this method. So we need to know. So our kind of giveaway for when we should use substitution is when we have, so let's write this down, when one of the equations is x equals something or y equals something. Okay, so when you look at your system, you look at your two equations, and if one of them is written as x equals or y equals, that would be like the indicator that, hey, I should probably use substitution. Okay, so something like that. Do you remember when's a good time to use graphing? Devin said that was his favorite. When's a good time to use the graphing method?
When there's like y equals.
When they're both in y equals. Both equations are in y equals. I would graph it because that's slope-intercept form. You got a calculator that can do it for you. But if you've got one that's in y equals and one that's in standard, I might be saying, I'm going to do substitution because it's set up for that. And then our last method kind of has a different setup here. So last thing we're going to do before we kind of jump into some practice is write the steps. Again, and I want you to keep this page out while we work on our practice because once you know these steps, it's very methodical. It's going to be just the same steps over and over and over again, but we got to know those. So if we write them down, I think it's going to help us learn them. Okay, and there's several, so bear with me. All right, step number 1. First thing we got to do is we're going to box the x equals or y equals part. Okay, so whichever one it is, we're going to draw a box around what goes after the equals. So x is equal to, box that expression. Y is equal to, box that expression. So start by boxing it. And then, after that, we're going to substitute. That's why it's called substitution. So we're going to take whatever's in that box, that expression, and we're going to plug it into the other equation. And I always draw an arrow, like this is where this is going.
Wait, what is number 2?
Substitute your box, so whatever you boxed around, into the other equation. So it's a replacement. You're taking the variable out, you're putting a new expression in. I made the analogy in sports yesterday. Okay? You're going to sub in a quarterback. You're going to take out the original quarterback. Okay, but you have to sub in the same position because that's what makes sense. So substitute the box into the other equation. Step 3, I always kind of do this little checkpoint right here. If you've done your substitution correctly, all of the variables should be the same in your new equation. So check that all the variables in the equation are the same. So you should be looking now at your equation. You might have multiple of them, but they're both x's or they're both y's. You shouldn't have different variables anymore after you've done that substitution because you can't do anything if they're different variables.
What was number 1?
Box the x equals or y equals. Step.
Why must we box
I just kind of put a box around like what I'm plugging in for. I mean, you don't have to do that if you don't want to, but that's just the way that I always show it. After you sub it in, now you're going to solve the equation for the first variable. And remember, our solving can mean that we have to go through our solving steps. We're distributing if we need to. We're combining like terms if we need to, and we probably will. A lot of times these problems are set up that you need to do distribute, combine. We're moving numbers over. We're dividing. We're just doing all those steps of solving equations that we did way back at the beginning of the year. We're continuing to do those same steps, those inverse operations. So solve for the first variable. We're almost done. There's only 6 steps. Then we're going to plug the value in and solve for other variable. So once you get your first one, you know that x is 5. You're able to then go find, okay, if x is 5, now I'm going to be able to figure out what number y is, or vice versa. Okay, but you got to find 1 first. Bulk of the work is step 1 through 4. Step 5 and 6 are pretty quick. Step 6 is just to write your solution as an ordered pair. Write solution as ordered pair, and it will look like this: x, y. So I want you to keep this paper on your desk, and then I want you to get out our puzzles. Okay, well, I'll leave this up, so if you're still writing, once you get out our puzzles, we're going to work a couple of those problems that I didn't assign you to do, and then we're going to spend the rest of the time like finishing the ones that the MRS and C, and then some of the other ones just for practice, and we're going to try to get that whole puzzle done here in class today, okay? So go ahead and get that puzzle out, and then again, I think it was pretty helpful to, well, that's really bright, kind of open it so that way you had some workspace and could see the problems at the same time.
Mom, what are you doing about?
3 problems. We're going to start with, oh wait, we already did M. We'll do A. We'll do A together, and then I'm going to kind of do like one of each type, and then you're going to just spend some time working on the rest of them. And we all want to make sure we have puzzle 1 and puzzle 2 done today. Puzzle 2. We're going to do a couple of the ones on puzzle 2. So we'll start with A, okay? I'm going to write it down. And go to the, like, some blank space, because you need some space for this. So x equals 8 is my first equation. The other one is 2x plus y equals 20. This is the very first one. Problem A. Okay? So remember those steps. Step number 1, we just wrote them all down, was to, well, first, let's look at our equation. Do we have one equation that's in x equals or y equals form?
Y equals.
You see a y equals on there? I don't see a y equals on there.
X equals.
There's x equals right here. So this would be like my indicator. Hey, x equals, I should be doing substitution. Now, what is x actually equal to? 8. Now, this one's kind of going to be bless you. It's going to be an easier problem because I already know the value of x. Okay, so I already know what x is. So here's my step 1. I'm going to box the x equals. I'm not boxing x equals. I'm just boxing what x is equal to. So just the 8. Okay? So that means I am subbing wherever I see an x, I am subbing in an 8. Where do you see an x in here? Right after the 2. So I like to draw an arrow to where I'm going, because I can only replace for the exact same variable. Has to be an equal sub. And now I'm going to rewrite my second equation, but instead of writing x, what am I going to put?
Y.
8. I'm going to put what x is equal to. And so this is the thing. You have to take the original variable out and put the new expression in. Okay? And then I'm going to finish that equation, which does have a plus y, and that equals 20. And then I want to make sure that I only have one type of variable in my equation. So the only unknown in this equation is a y, where above there was an x and a y. Now I'm down to just y, which means I can solve for it. I'm going to do some math. This is now step 4, solving. I need to clean this up. What's 2 times 8?
Super 16.
So I have 16 plus y equals 20. And now I'm solving for y. So what am I going to do, Keon? I'm going to do to get that y all by itself.
So you make the...
Because we kind of taken this practice day, so we did some more substitution practice. Think we're getting better at that, grasping onto that. I'm going to do a little intro to elimination. So I'm kind of going to split elimination into 2 days. We'll do an intro lesson today. We'll do some of the more challenging problems next class and practice, and then I kind of move some stuff around so you can see when your first CFU is and stuff. It'll be later in the week. So ultimately, we're still a ways away from the test. The test isn't until the 15th, so it's still 2 weeks. And elimination is really the last new lesson. After that, it's just more of like putting it all together, continuing to practice it, because it is a lot. But you'll have a few days, again, of just reviewing and, like I said, just kind of piecing it all together. But by the end of Monday or Tuesday, y'all should really know, like, all the material. So just be aware that's when that stuff is happening, and then that last week we'll have time to get retests and whatnot done, and then go on a break. So this is our final method. It is an algebraic method. And again, we're just going to do a quick intro here. It's typically elimination is the one that people like better. I don't really know why that reason is, but it's just usually everyone's favorite. So hopefully it will be your favorite as well. So we are on page 18. So we're filling this out again. We've kind of filled this out a couple times. And it says a solution to a system is a blank that both lines have in blank. Okay, so when we find a solution, what are we finding?
No problem. X equals y.
Correct. So what do we call that when we put it together? An x and a y. Is it order pair? Or shorter, because I don't think I can fit all of that. It's a, can we say point? Order pair is exactly the same, but I can't write that in that space. So I'm going to say point, and it is an x and y. And it's the point that the lines have in common. Nope. The solution is what they have in common. Or where the lines meet, intersect, cross, all of those work. Okay? So, big picture, we're still kind of finding that same thing, but elimination is an algebraic method, so we're not looking at any graphs, but we still have our one solution, no solution, all solution, all those things. Elimination is the easier method. Remember, I said it kind of depends on the setup. If they're both in slope-intercept form, we're thinking graph. If one of them is x equals or y equals, we're thinking substitution. Elimination is best when both equations are in standard form. Remember what standard form is?
Yes.
I say that they are lined up. Okay? So in standard form, you have x over x, y over y, equals over equals, number over number. And so that, to me, if I get a system and both of my equations are like that, I'm thinking, hey, I want to do elimination. And basically, the whole point of elimination is to just, it's in the name, eliminate one of your variables, okay? So what we end up doing is we have to check our equations and look for what I call a zero pair. Write that down. We're going to define that in just a second. This is star-worthy because it's important. You need a zero pair, and we will define that in just a second. But that's the first thing, is we're going to look for, do we have a zero pair? If not, we need to make one. And that's what's going to make this, I think, a little more challenging, is figuring out how to get the zero pair. But we'll work on that over the next 2 days. And then once you have that zero pair, you end up adding up your equations, and one of your variables zeroes out, eliminates out. Okay, that's the big picture of it. So what is a zero pair? Well, that's two things that add to be zero. So if I gave you a 2x, What would make that add to be 0?
Negative.
-2x. Okay? 2x and -2x is a 0 pair. What about a -5y? Positive 5y. So to be a 0 pair, here's what we need. We need the same coefficient. I'm using some vocab. What is a coefficient? The number before the variable. So those need to be the same. Okay? But to be 0, they can't just be, you can't have a 2 and a 2. You have to have a 2 and a -2. So they need to be the same number, but opposite sign. That's going to make them add to be 0. With elimination, you got kind of some freedom to decide how you want to solve it. There's lots of different routes you can take and still get the same answer, but you want to try to think smarter, not harder, okay? So what variable is easier to be my 0 pair if it's not already set up? And then you still have to go back and solve for that other one. But it's kind of like you got to analyze your x's and then analyze your y's. So let's try number 1 together. So it says solve the system of equations. Same instructions that we've been doing for the past 3 days. But let's look at our setup. Both of my equations are in standard form. X and y are both on the left-hand side. So you see how they're lined up? X over x, y over y, equals number. So this is making me think I should do the elimination method. That's the first thing. You got to decide which way. So let's analyze our x's. What are the coefficients of my x's? 3 and 2. Is that a 0 pair? No. So let's look at the y's. What are my coefficients of my y's? -4 and +4. Is that a 0 pair? So let's take out the y. We don't even have to change anything. So now I'm going to end up adding up these two equations. So I'm going to put a plus sign on the outside, and then I'm going to draw a little equal sign. And I'm just going to go vertically, and I'm going to add. What is 3x plus 2x? 5x. But then what happens with my y's? -4y plus 4y. They eliminate. They cancel. They zero out. That's what we wanted. Goodbye, y.
I don't have those problems.
We're on page 18.
My bad.
13 plus 2 is
13 plus 2 is 15.
15. And so now, look at this little equation. 5x equals 15. How do we solve that? Divide it by 5. And so real quick, I get that x is equal to...
No. I was going to solve it.
Okay, you can... We're not done. We're not done.
And hey, also, hey Devin, just because he says it's 3 doesn't mean he's right. So you can also check to see if he's right.
Pretty.
Sometimes we say the wrong answer. We have to verify.
Yes,
You can check it.
verify is good. Okay, but we're still solving a system, which means we need an x and a y. So are we done once we find this? No, so what do we need to do now? We need to find the y. So we, in order to do that, and again, you've got freedom. It's the same idea as what we did with substitution. Once we found our first value, we would take that value and plug it in. In substitution, we typically went back to the isolated one because that was quicker. In elimination, you get to decide. Do you want to plug in x for the top equation or the bottom equation? So plug in x equals 3. And y'all want to go in the bottom equation? I agree. I would do that because there's not negatives in there. So we're going to write the bottom equation. It says 2x, but what do I know x is now? 3 plus 4y equals 2. And now I just have to solve this equation. Now, it takes a few steps because it's in standard form. But I can multiply 2 times 3. That would be 6. 6 plus 4y equals 2. And I'm just back to solving. Again, we're just like solving in circles here. So subtract your 6. And then divide by, the humming needs to stop. and then we're going to get a solution, which we will write as an ordered pair. Okay? So here's the thing that's just weird about systems, and I've said it time and time again. You are constantly finding the exact same thing. It's just the way that you find it are all very different. Okay? But this is how your elimination process works. You check that they're lined up. You check for a zero pair. You add them up. Find one, find the other. Okay? Let's look at number 2. Are we lined up?
No.
Do we have a zero pair on our x's? 2 and negative 2. So we're good. We're good to start adding. So I add. 2 plus negative 2 is? Cancel out. Now I look at my y's. Negative 3 plus 3.
Cancel.
Also cancels out. So if this happens, I'm going to get one of my special cases. If they both cancel out, they both add to 0.
Looks like Krista.
I need to put a 0 right there. Okay? But this is going to be one of those I'm looking at, am I left with a true or am I left with a false? So 0 equals 19 plus 21 is?
So 0 equal 40.
No. 19.
So if you get a false statement, then what is your answer actually? No solution. So what does that mean about those lines? Hush.
They're parallel.
Those lines are parallel.
No salt.
And what do we know about parallel lines?
At the
Same
slope.
Same slope, but
No.
okay.
It was supposed to be no.
I don't think I'm going to ask that question anymore because we have to sing about it.
We've learned it. Ask it all the time.
So my point to that was that if I look at the way this is set up, I cannot see the slope in standard form. So I wouldn't be able to look at that and be like, oh, they're going to have the same slope unless I actually solved it. So if you take the algebra route, you can still get parallel lines. They just you don't know that they're really parallel just from looking. And so you're looking at the true or false
That would
here.
actually take longer.
It would take longer.
This is a little easier route.
Yes, it's all about, these problems are so much work. We are all about trying to find the easiest way. Okay? All right, I'm going to do problem 3 with you, and then I want you guys to try problem 4, and then we're done for the day. So I want you to pay close attention because number 3 is going to kind of start to be like we're taking it up a notch, okay? And this is how a lot of your problems are going to be. So if I look at 3, first thing, I'm lined up. X over X, Y over Y, number over number. I'm going to put an E for elimination because that's a process that I'm going to use. But I'm not ready to do my plus sign yet. Not ready to do my plus sign. I have to analyze my variables. I'm looking for that zero pair. So what are my coefficients on X? On X. 8 and negative 3. Is that a zero pair? No. All right, so let's look at Y. What are my coefficients on Y? What are my coefficients on Y?
Is it 1?
1 and 1. And they're both positive. Is that a zero pair? What is 1 plus 1?
2.
Okay, so we have a problem. We don't have a zero pair. It's usually going to be this way, people. You are usually not going to have a zero pair. So, in order to make one, we can manipulate one or both equations, but we can only do it by multiplication. So, if I have a positive 1, what would be the zero pair to a positive 1? A negative 1. So I need to say, okay, I got to change one of these positive 1s and turn it into a negative 1. Now, options. You can change the top one to the negative 1, or you can change the bottom one. Dom, which one do you want to change, top or bottom? Top, okay? So we're going to change the top one. But here's the question. How do I turn a positive 1 into a negative 1 by multiplying? Think about what I just said. I need to multiply positive 1 by something to make it a negative 1. Raise your hand if you think you know what I need to multiply it by.
Multiply by
7?
Negative.
Negative
1.
1. Very good. So I'm going to... Dominic picked the first equation is the one that he wanted to change. So let's all do it this way. Devin tells us if I want to turn a positive 1 into a negative, I just have to multiply it by a negative 1. Perfect. here's where you got to be careful. When you multiply an equation, notice, what did I put around the entire equation? So when I see parentheses and I have a number outside, I have to distribute that negative into, how many little rainbows did I just draw?
Rainbows.
3. This is what people make mistakes on. If you change an equation, you have to change the whole thing for it to still be legal, math legal, okay? So -1 times positive 8x. I'm going to rewrite it over here. What's -1 times positive 8x? Negative 8x. -1 times positive 1y.
Negative.
And you don't have to put the 1. You can just put -y. But I kind of like having the 1 for this. Equals, one more time, what's -1 times -16?
Bernie, I have a question. Is it always multiplied by -1? Or
No.
just because that one's 1?
It's because they were already the same number, but I had to change the sign. So to answer your question,
So it's like if there was another 8, we would do the same thing about 8.
What?
That's the
Oh.
wrong-
you just have to, there's different ways. Shh, I'm trying to answer a question.
Yeah.
There's different ways that you can do it. It just depends on what you have. Like, and we're going to get to more next class, but like you might need to change a +2 into a -4. So you would have to multiply by a -2. Like it kind of depends, but we're going to build on it. I think for today, we're going to kind of be at this level. Okay. Now, I do not need to change the second equation at all. So notice I'm just writing it down exactly as it is. But I wanted to kind of bring it over to the side where my work is. So you can change one or you can change both. It just depends on what you got. But now I have that 0 pair. So there's some prep work at the beginning. Here we go. We're going to add -8x plus -3x is -11x. My y's are going to eliminate. They zero out. That should happen. One of your variables should eliminate. That's why it's called elimination. And then 16 minus 5 is 11. And now I have a quick equation that to solve. I just divide. So what is x actually equal to?
-1.
Okay, 11 divided by -11 is -1. So I found my first variable.
We're done.
No, we're not. We're close. And now I need to
Replace it in one of the problems.
replace it in one of the problems. All right, Noah, do you want to plug it in
Yeah, Noah.
equation 1 or equation 2?
I think we're gonna do equation 2.
Equation 2. So plug into equation 2. Okay, you're about to do one of these by yourself, so make sure you're paying attention. So it says -3x, but what do I know x is? -1 plus 1y equals what?
2x. I mean, -5.
-5. Okay, and if you wanted to plug into the top equation, that's fine too. What is -3 times -1? 3 plus 1y equals -5. I'm going to draw my line because I'm solving now. I have to subtract 3 on both
And that
sides.
goes back to B2.
Mark.
So this is going to give me 1y or y equals -8. And then since the coefficient of y is 1, I don't have to divide by 1 because it's not going to change it. So what is my actual solution point?
-1, comma,
-1, -8. Very good. Okay? Yes. I would like you guys to try number 4. And when you finish number 4, show it to me or coach. You can pack up your stuff, study for biology, whatever you need to. We are going to continue elimination on Monday. Yes.